Okay guys, so what we have here in this glass is some soda. So you can see that there are a lot of bubbles in there. And what we're gonna see is what happens with that, those bubbles are carbon dioxide, and what happens when we submerge something in there that it has maybe some cracks or some ability to trap that carbon dioxide. So what I can do is I can submerge this pipe cleaner, and hopefully you guys can see compared to how it looks on the top of the pipe cleaner, so whatever is out of the water, and what is inside. You can see that there are very tiny bubbles. Whoop. There are very tiny bubbles that are actually being trapped in the pipe cleaner, and that has to do because you can see between the little hairs of the pipe cleaner there's empty space. So that means that the carbon dioxide, it decides to accumulate there. Now, what will happen if I put something else, like a Mentos? In this situation, I'm gonna drop it over there, and you can see, okay, how, I guess I can tilt it. You can see how all those bubbles are actually coming out of the Mentos right now. And that has to do because when we think about this Mentos, it's not as uniform. The coating is not as uniform as you might think. It's actually full of cracks and dents. So that means that CO2 gets trapped in there. There's a lot of molecules that go in there, and then eventually they start bursting into bubbles. So this is actually the principle that you can think about when you have heard probably the Mentos and Coke experiment. In the Mentos and Coke experiment, what happens is that you have carbonated soda that has people have added carbon dioxide to it, and therefore that carbon dioxide, which is a lot, it will actually get trapped in those Mentos that you put in, and the more Mentos you have, the more CO2 gets trapped. Eventually they want to come out, and that's when we see that what is called like an explosion. Okay, look at that. I just put another one, and you can see how this is pretty neat, how the CO2 starts trapping, it gets trapped in the Mentos, and then eventually starts evolving. Okay, so this is just the background of what we should actually see in soda. We're gonna try it with Mountain Dew, and we're going to try it with Pepsi and see what is the difference of them. Okay guys, now we're going to have my assistant, Tony. Hey! And she's going to do the demonstration of the soda with Mentos. So let's see what happens. You can, whenever you want, Tony. Whoa!
Didn't shoot up very far.
No.
That was a little disappointing.
Okay guys, so now we're going to try with Pepsi and see what happens. When you're ready, Tony. Oh, there we go. That was much better. Okay, so you may be thinking that what happened right here was the difference in composition of Mountain Dew and Pepsi, but it's actually not just the amount of sugar or any of that. It's just the amount of carbon dioxide or CO2 that is inside. The more you have, the higher eruption you have. So maybe the one that we have was a little bit older, the Mountain Dew, than the Pepsi. Definitely we use a bigger bottle, like a 2 liters instead of a 1 liter that we use. You're going to get a higher eruption. Some people, they swear by diet soda. You can try it, but honestly, the only thing that actually makes this eruption is the carbon dioxide. So the more that you have, the higher eruption that you're going to get. Also, you can try with a bottle that has been cooled in the refrigerator compared to one that has been sitting outside for a while. So you're going to see the difference between a warm and a cold bottle. Of course, in the warm bottle, the CO2 is actually removed from the liquid. So it's going to rest between the liquid and the top of the bottle, and it's going to be maybe more available. But, those are things that you can try, and again, just be scientists about it.